Hey everyone, welcome. Today is the 5th of March, and we are approaching total eclipse and also the change of time zones here in the U.S. We're going to do the usual Dallas Personal Robotics Group thing and go around the table, talk about our projects and questions and other topics normally more or less related to robot-y things. We have a queue started already. I will put it in the meeting chat here. Basically, we have first Mike, then John, Brad, David, Pat, Ray, and open mic. And with that, probably from this point on, I think mainline act Paul will kind of keep us facilitated. And well, we start off with Paul and Mike. So there we go.
Thanks, Carl. One question before we move out. Did you get confirmation from DMS on those reservations?
Oh, good point. So I did get confirmation that I can reserve the Saturday meeting rooms. Right. And in terms of the other things, he's going to have to talk to the DMS makerspace to figure out a CTO guy at the makerspace, so-called CTO. They're going to figure out if they can just flip some calendar dates in the scheduling system, or if they want me to reload them.
Okay, so I think the bottom line to announce here for everybody is that whereas I'd previously announced that the in-person Saturday meetings were going to be on the third Saturday of the month at starting at 10 a.m. We found that we were unable to book them. I should have thought to check first, but I didn't. And the meeting room that we want to use right by the door was unavailable. So we have we're switching to the fourth Saturday of the month. So that means that the March meeting will be on March 23rd and the April meeting on March 27th. The May meeting we're going to use as a Roborama practice on May 25th, and then Roborama itself will be on June 8th. Did I get that right to your understanding, Carl?
June 1st.
June 1st. I'm sorry. You're right. Yeah. June 1st.
I'm just copying and pasting what we discussed with the makerspace people. So
yeah. So Roborama is pushed back a couple of weeks. So give everybody a little more time. And the regular meeting, it turns out that the third Saturday and the fourth Saturday were almost equal in terms of members' preferences, and so we went with that because we could get the meeting room that we wanted. So I think that's all the news from DPRG that we've got. I'll be sending these details out to the list, but wanted to surface it here in case anyone had any comments or thoughts. If not, we shall move on with Mike W. And Mike, I'm excited to hear what you have to say. Do you have a microphone this week?
I hope so.
You do?
Yeah, it's a different computer, but the other computer was good on a Zoom meeting. Oh, well, so it probably works too, but okay, yeah. Don't know what happened. Yeah, so I've been working on my robot for that also does the 6CAD. And so in one of my windows, I have my little course set up, and I was going to give a demo. And of course, demos are meant to fail, so we'll see what happens.
Hey.
So I'm going to give it a start. So it's going to try to grab the cans and put them into the bathroom door.
Ooh.
The goal. Yeah. So start.
So should we be seeing the robot?
It's in another window. If you pin the other window. Oh, look at that.
Oh, that's nice.
Yeah, so I have a waypoint set right before the door so that it can align itself to go straight into the door if it's at an angle. So it went to the waypoint, it went to the door, and then here's the drop-off waypoint here. It backs up a little, rotates, comes out to the waypoint right inside the door, outside the door again, and looks for another can.
Oh, that's awesome.
And it's a little slow and it's too deliberate, so I need to speed it up. But it's functional. I'm using ROS 2, but I'm not using the navigation stack. I still want to learn how to use it because these case statements are getting complicated, and they have a good behavioral tree. So and a lot of stuff I'm doing, I think the nav stack can do as good or better, especially when I want to do. I want to avoid obstacles and then map the room to keep the odometry calibrated. But so I when I look at it, I see the odometry drifting a bit. Happy to see it. and it has issues, but hey, it's fun. Guess it's gonna go do that one. Maybe. Yeah. So it's a little too skittish, trying to figure out what it's doing. The code is really bad. I gotta straighten it up. Because at one point you'll notice that it moves towards the can and stops. That's when it's handing off between the blob detection with the camera and the time of flight sensors.
Oh, that's so. What is this running on? A Pi 3, 4?
Pi 4.
Pi 4. Okay.
Right. With an open MV camera and an array of time of flight sensors.
And was the code you used something a starter code found online, or is it all this portion of it? The seeking and finding and grabbing. Is it something all yours, or you kind of started from the
beginning? Right. Yeah.
You wrote the whole thing. Okay.
Yeah, and I'd like to use the navigation stack in ROS, but each time I go to it, it just makes me crazy trying to figure out how to implement it. But yeah. I need to really say, okay, I know what I want to do. I know how to do it. I know it can do it. Can I do it in the navigation stack, which is, I really need to start using it. So now I was going to go back to that waypoint and then start looking for a can. And of course, there's no cans.
So right here, is it detecting cans? Is that with the time of flight? Is it looking for the width of a can here?
It uses the OpenMV blob detection to detect cans.
Okay.
When it gets close to a can, then it switches over to the time of flight, and it's an array of sensors. And so I sort of try to line up what I think is a can to the middle sensors, and then approach them.
Okay, got it.
Until I get to a certain distance where I can grab them. Because the time of flights are really good at measuring distance, but they're a little rough in terms of angle. But it's good enough. If I'm close to them, it's good enough.
Right. That's awesome.
Yeah.
Your code here, are you using just state machines within your code to transition, to find the next waypoint and and all of that, or how's your code structure set up?
Yeah, it's a case. It's a state machine, case statements.
Okay.
And to sort of make the code a little easier, I have smaller case statements like go to waypoint, and then I'll call that within another case statement when I'm trying to do stuff. So I've been trying to modularize it a bit.
What language is the code written in?
Python. Yeah, I had some issues in ROS. There's something called a transformation. The package is called TF2 for transformation, I think, and like there's a couple transformations. I could go from the map to the odometry transformation, then odometry to the base link, which is the robot, and then base link to CAN. And you're supposed to be able to say, give me the transformation from map to CAN. And it tried to do it, but it would throw an exception going, I don't like doing that because I have to extrapolate into the future or something. And I tried using different Google searches to say, fix it by doing this and that and that and this. None of them worked. And I'm getting the feeling that the C++ is, well, everything's, the guts of ROS and their libraries is C++, and they put a Python wrapper around them to help to allow Python to use. And I think that there's a bug in the Python for transformations because all the ones that seem to work are the C++ ones. Like, oh, we have no problem. It works for us. but I did it by getting a transformation from the map to the robot, and then another transformation from the robot to the CAN, and then the simple math of just adding the X and Y values gives you the complete transformation from map.
Did you configure those transformations? I mean, ROS needs to know what they are, right? So you either have a static transform set up, or you're publishing it as part of one of your, part of your code. You're publishing some transform. Either way.
Well, I got, like, my waypoints are static, and I think the map to odometry is static because I don't have SLAM mapping involved right now, and then I'm using the Kalman filter for my odometry, and it wants to control the dynamic transformation between odometry and the robot. And then I have my own dynamic code to go between the robot and the CAN. Because the sensors are on the CAN, so I come up with the transformations for that, and then publish them. It's not called publish, but I publish the transformations every time I sense the CAN, which is like 10 times a second. So it's
cool. Very cool. Gold star, big gold star. Hey, were you going to show that video I made, or shall I, if John will let me jump in, because the video would tag right on nicely on the end of your presentation.
Works for me.
Well, let me go find it, and I'll jump in between.
No, I've got it ready to roll.
Oh, go for it. Yeah.
Okay. So Mike's got a really interesting sensor configuration. He's got 3 time-of-flight sensors pointing out, at I guess 45 degrees or something. And last week I showed a demo of a GUI displaying an 8x8 time-of-flight sensor array. And Doug suggested that I should get a bag file from Mike and get the GUI to display it. So I did that. And so what I'm going to show is Mike's bag file, which is in the same location that he just demonstrated, where and what he said, his scenario is the robot sees a can a meter away using blob detection. The can was placed right in front of it, so it didn't have to scan. And then when it gets about a third of a meter from the can, blob detection stops working, so switches to time of flight sensors and cautiously drives to the can and grabs it. Then it rotates 90 degrees, drives about 2.5 meters to just outside the goal entry, then drives 1 meter into the goal area, drops off the can, then it backs up a half meter, rotates 180 degrees and drives half meter out. And then it scans and locates one using blob detection inside the goal area that it had dropped off. So what you're going to see, this is sort of like looking at coarse resolution video, but I think it's just the neatest thing. Oh, come on. Oh, why can't it share?
The time of flight sensors, I have 3 sensors, and each of them is an 8x8 sensor. And one of them looks straight ahead and it has a 60-degree field of view. And then the other 2 are mounted at a 30-degree angle, and they have 60 degrees. So it gives me about a 180 degree, so I can use it for obstacle detection as well as can location when it's close. So when you see the thing, it's like those are each of my time of flight sensors. But there's actually 3 ICs. Each of them has an 8x8.
Are you guys seeing this?
Yeah.
Yep.
So you're starting to see the can popping up at a distance in this kind of area as the robot drives straight towards it. Now it's getting closer, and it's at 0.3 meters, and then it like cruises on in slowly. And there's the can, and there's like some kind of wall in the background there. And then the robot rotates 90 degrees, so we'll start to see so it's grabbed the can at this point, and the sensors are reading 0.11, and it's rotating, so the wall is rotating out of view of the sensors. And then it goes towards the bathroom door, and so you can see the 2 door edges getting in closer on either side of the can here. And so now it drops the can off. And backs out. And now there's like a wall or something off to the right. And then it's doing a rotate here. And you can see the bathroom door walls here, and now it's found the can again, the can in the goal, right about here.
But it's ignoring it, so yeah.
So it goes in, it's picked it up again at 0.11.
Oh, well, that's before I hit it, ignore it. Okay, yeah.
Yeah, that's before you had it ignore the can in the goal. So this was a intermediate step, but I think it's pretty neat to kind of see sort of very coarse resolution video. So anyway, that was all I had to present on the back end of Mike's excellent demo.
Okay, thank you, Paul.
That's cool.
That is cool.
All right.
Hey, Paul, just for the record, what your GUI is using what ROS package? What's the analyzing tool? I wasn't looking at
that's not a ROS package. I thought I wanted to learn how to write a GUI, so I learned tkinter, and which is like a Python GUI package, and integrated it with a ROS listener, and then I played back his bag file, and the ROS subscriber was subscribed to the topic on which he was publishing the range of 24 sensor readings horizontally by 8 rows vertically. And then it just gave the ranges to the GUI app, which rendered them.
I'm sorry. I should have phrased it. What was the GUI app? I'm doing it for the highlights of the meeting. That's why I want to know.
Yeah. No, it was a custom. It used the Tkinter, spelled with a capital T and lowercase Kinter, GUI package, Python GUI package, but it was my own code, running, doing the display.
Could you just write the package name in the chat so I can grab it? Because I think you said Tkinder, but I'm not sure that's what I. Oh, well, I did have it right. Okay.
Okay, and so this is the sensors. Like this right here is, of course, the camera, and then this is one sensor on the right. Then this is the forward sensor. And then this is the sensor on the left.
So those are 90 degrees?
60 each.
Okay.
And then I made this piece of plastic at 30 degrees, so it gives me a pretty good 180 field of view.
Yeah. Man, that's the coolest robot. The only problem is its peak.
Is it what?
Well, that's the plastic I put in. Yeah. So, and then this is I'm working on the claws, but those are the claws. And so I have a claw on each side, and each side has its own servo.
So Mike, that's 60 degrees, not 30 degrees, right? Otherwise, you got parallel to the front. You got parallel to the front. I'm just saying how they're mounted. And then on the side, 60 to each side. Okay.
Mm-hmm. Yeah, the spread on is like 30, 37, something like
60.
that?
They're about 60 degrees.
Okay.
Yeah. So I know a lot of people working on claws, and I like to play with claws, and so I did it sort of like I did in my robot last year, and had a servo on each side, just to keep the mechanics real simple.
Mm-hmm. Yeah, I thought that use of the 3 Tof sensors to get a all-around obstacle view and seeing it on a range display was really pretty neat.
Yeah. Thank you, Paul. Okay.
Okay. Thanks, Mike. John, you're up next.
Yeah, so a couple things. Just wanted to show sort of progress update on my Robomagellan robot. It's a RC rock crawler chassis with, so it's got an oak D light. I've got a big 3D printed roll bar going over top of it now. Raspberry Pi 4 on the back. There's going to be a custom board here for the microcontroller and whatnot. I've got a powered USB hub on this side and a 1 terabyte SSD for logging and stuff like that. So I'm not logging stuff to the little SD card on the Pi. And then I've got these 20 millimeter carbon fiber tubes that I bought quite a few years ago. So I have the GPS. This is an Adafruit Ultimate GPS, and there's 3 of the simpler time of flight sensors mounted at one straight back and then at 45 degrees. This is for the back, pointing backwards, for when it's backing up, so it doesn't run into stuff. The main obstacle sensor is the oak D light on the front, and then up at the top of the mast, I've got one of Adafruit's 9-axis IMUs with the Bosch BNO 085 sensor, quite a ways away from everything. So hopefully that will work pretty well. So I'm hoping to get this thing running in the next month or so, but we'll see.
Can you can the oak D light detect distances close in?
Not really close in. So I've also got right in the front bumper here, and you can see it, but it's kind of dark, but you can just see the light reflecting off it.
Right.
That's another one of those time of flight laser sensors mounted in the front. So the idea, I mean, this is for Robomagellan. So the idea is, or RoboColumbus or whatever, you have a cone and the camera can, recognize the cone because it runs object detection inside the camera. It's got the depth map. So that works out to about maybe a foot in front of the robot. And then the laser sensor will be able to see the cone by then as you approach it. And once you get a really good measurement within a couple inches, you can just use odometry to push forward that far.
Yeah.
This thing has an encoder. As I say, this was an RC rock crawler, but it's got a brushless motor, the main motor, and these ones have like a transmission and a couple drive shafts with differentials that are all locked. So it's four-wheel drive all the time. But I have an encoder on the motor shaft, quadrature encoder that feeds into my. This is the microcontroller board I'm using. This is a WeAct Studio STM32F405, basically a MicroPython board. You can get these off Alley for like $10, which is really nice. And so I'm feeding all of the stuff into that, and it's going to decode the servo signals from the RC receiver, because I'll be able to switch this to RC mode if I want. And it will also control the steering servo and the ESC for driving and stuff, and get data from the IMU and all the other sensors. And then the Raspberry Pi will do all the high-level stuff.
Cool. Very cool.
Very cool.
So that's that. This is my other project that I'm working on. This is kind of cool. So I've turned this into kind of a wearable. What it is inside is one of these little round screens from WaveShare. And so this is a 240 by 240 touchscreen. And on the back, it has an ESP32S3. And a battery charger and a battery plug and a few other things. So this thing I program in MicroPython, and let me just power this guy on, and you can display graphics and stuff, and of course all the text is backwards because a camera, but it does touch, and you can drag. Well, you can't see very much from there, but you can drag things sideways, and so I have a full sort of GUI, touch-based GUI system built. You can have buttons and labels and lists and updating stuff, and stacks of windows, and you can go back using a swipe up all the way back to the very beginning again. So the idea is I call this my universal robot configurer. ESP32 has a really neat feature called ESP Now that allows you to do peer-to-peer networking directly between ESP32 chips without needing to configure Wi-Fi or Bluetooth or pairing or anything. You basically give it the MAC address of the chip that you're sending to, and you basically just say send this string, and it's like using a UART, and it sends it at like megabits per second, and it has 50 to 100 meters of range. Time of view, and the idea is that I also have a trigger. This is basically just a fancy handle for a button, and I've got a little plug on the side of this thing, and I can take this cable that I've got here and plug it in, and then I can plug my trigger in, and now this thing is a fail-safe. So when I put this on my wrist and hold on to this thing, I can trigger the button and hold the trigger, and this thing can read that button and update internally accordingly. So that's kind of cool. So this is going to be my fail-safe from my Robomagellan bot, but it's also going to allow me to configure, because it's got this full GUI with the touchscreen and stuff. I can configure options like, you know, if I want to build up a set of waypoints and have multiple sets of waypoints, and I say, okay, well, for this mission that I'm going to run right now, I'm going to do like from the start cone to bonus cone 1, and then I'm going to go from bonus cone 1 to the finish cone. And I can set that up on the touch screen here, and then send it to the robot over ESP Now, and then just start the mission. And because I'll have an ESP32 on the robot as well, listening for that. And the cool thing is, of course, I'm going to put an ESP32 in all of my robots. And so this will allow me to configure any of my robots, and anybody who's built robots and used them anywhere outside of their house knows what a pain in the butt it is to deal with things like Wi-Fi at events, or trying to, you know, hook up USB or hook up a monitor to a Raspberry Pi so you can connect to Wi-Fi and get the IP address so you can SSH to it from your laptop and whatever. And you don't have to do any of that with this. With this, it's going to be basically a direct connection between this and the robot, and I can configure, you know, if I want to get my Raspberry Pi on Wi-Fi, well, that'll be one of the options, that I can just punch in the Wi-Fi password into this thing and send it directly to the Raspberry Pi and have it connect to Wi-Fi. You know, if I want to do some actual, you know, with my laptop working on the Raspberry Pi, but otherwise I can just do simple type configuration stuff like you would do when you're actually running the competition from this directly. And the same thing goes for, you know, like a 6-can robot, or my quad walking robot, a mini sumo, or, you know, in any of those kinds of robots, you could use something like this to talk to them. And because it's a generalized GUI that I've built, you can create your own windows and stack them together how you like, and create lists and buttons and whatever to send data back and forth.
That is, I got a question for you. If the 2.4 is saturated with people accessing stuff, is that going to affect you?
Probably not as much, because it's not trying to maintain a connection between the two devices. It's a burst thing. So in ESP Now, you basically create, like in MicroPython, it's about 10 lines of code. You create an ESP Now object, you give it the MAC address of the guy you want to send data to, and you say, send this byte array. And on the receive side, you create an ESP Now object, and you basically sit in a loop polling, waiting for that data to come. And when you get the data, then you do something, and you can maybe send data back or whatever. But they're kind of instant on connections, and you can you know, set them up so that it only creates that connection when it's actually sending data.
So is it a datagram oriented protocol as opposed to a stream oriented protocol?
It's exactly like a UART. So you literally have a send, and you send to a MAC address, and here's the string or byte array that I want to send. And you can put whatever you want in there. It takes care of all of the protocol side of things and packetization and whatever, but you can send, like, I think you can send up to 200 bytes at a time.
The point I was actually asking was, is it fire and forget like UDP, where
it
no
can be
delivery?
It can be. They have a broadcast mode where you can send to every single ESP32 in the vicinity that's listening, but if you specify a recipient via MAC address, it will do retries and stuff like that to actually send it.
Oh, okay.
Yeah.
Thank you. That was what I was.
A callback that says whether the transmission was successful or not. So
yeah, it's a really powerful protocol, and I can't believe that I've gone all this time without knowing anything about it. It drives me nuts, because I would have built this. Well, I wouldn't have built this years ago because the tech for this wasn't here years ago. But this thing is friggin' amazing. Touchscreen with a built-in ESP32. It's got 2 megabytes of PS RAM and something like 16 megabytes or 8 megabytes of flash, and it's even got a 6-axis gyro / accelerometer for doing upright detection, and if you want to build a smartwatch, well, you can do step counts and things like that. And the battery chargers. What's that?
Ray has a chick bagged it too.
yeah, that was another ESP32 where I used ESP Now. Yeah, I was thinking about that. I don't know whether it's not following the Wi-Fi protocol. ESP Now is a little bit different, but if you have like a bursty transmitter among many Wi-Fi users, that could be like an electronic countermeasure for your competitors. It's like it'd probably screw them up, but it wouldn't screw you up.
Well,
yeah,
but you're still playing a game of chance, right? Because if the bursts happen to coincide and there's not enough bandwidth in it, and so I was just wondering, have you tried the simple microwave popcorn test, where you try and have a steady stream of bytes, and then you just make and you put your transmitter receiver pair in the kitchen near the microwave. Try some popcorn and see if you have a good dropout. Or if
I have not tried that, but I'm not planning on using it.
Jan, can you put the link for that circular board?
Yeah.
Yeah. And do you know if that's I know I saw that Adafruit had a circular display pop through on their new products, but I don't remember it having an ESP on it.
There's a whole bunch of them. You can get them with an RP2040 if you prefer. You can get it with the ESP. I mean, Seed Studio sells this is their version of it, and it's just got a socket on the back that you can plug any of their ZOW chips on. So, this is the Seed ESP32S3 ZOW form, and it will plug directly into the back of this guy. But this is a bigger screen. It's the same size display, but it's got a big bezel around the edge, and it ends up with a socketed chip on it being a lot thicker. And since I wanted to make a wearable, I wanted something a little bit thinner. And so this guy has almost no bezel, and it's a lot thinner with the ESP already on board. And like I said, and there's a guy named Russ Hughes who's built a really nice MicroPython graphics library for the driver chip that this uses, which is what I'm using for my menu GUI system. And my GUI system is completely event driven. It's everything drives off the touch screen generates a touch interrupt whenever you touch it, move, or lift your finger. You get it. There's an interrupt pin, and I have an ISR callback in MicroPython, and everything drives off of that ISR. So the main loop in my code sits in a tight loop and does a sleep. That's all it does. It does nothing.
Replace the handheld? I think it was a 900 megahertz radio.
Yeah. So I was originally, I had this handheld thing that had an RP2040 and an Adafruit 916 megahertz radio, and that was okay for a failsafe. But when I found out about ESP Now, and I had these Seed round touch screens, and I was playing around with that other little white robot that I had one of these sort of mounted in it, and And then I found out about ESP Now, and it's like, holy crap, that makes, because configuring robots is a pain. It really is. Like even what Mike, he's using a joystick to start his mission, on his 6-can robot, and it's, you don't get any feedback from that, and you're very limited in terms of what you can do, and you have to build this whole thing for every single robot. Whereas, if you build a system like this and you put an ESP32 in every robot, which is, let's face it, not a terrible thing to do nowadays, you get all this stuff for free.
Yeah, I thought it was really an interesting idea, and I know Ray's been working on a watch, on a robot watch, and so I thought it'd be really, I guess, at a higher level. Many of us either use buttons on the robots to like kick off missions or configure different parameters, or we deal with the Wi-Fi grief that you alluded to. And except for Ray, who's got his own version of a smartwatch, and I was thinking this could be something of really broad interest. So I was interested in, so you've described how you're based on a general purpose GUI platform. I didn't know what Ray's watch is based on in those kinds of respects. But I thought it was pretty neat, and I'd be interested to understand a bit more, what your watch is like in those terms, Ray, in terms of GUIs, touches, software frameworks for creating menus and such.
Yep. Well, this one, this is the case for it, but I can't find it right now. Anyway, it was another ESP32 board, the WT32.SCO1, and there's an SCO1 Plus, but I liked the kind of the layout of that one. It was a lot better. You can use their graphics tools to, and that's kind of shown with some graphics on it. I'm just using it purely as text, and I don't, the push button, or not the push button, the touchscreen part of it is active, but it doesn't send anything to the robot, and there's no menus. There's just a screen of, it was for the outdoor robot, so it shows like, in Dave Anderson's, variable names, the meters to go, how far you have to get to your whatever goal you're trying to get to. It shows the target angle, the angle of the platform. What else? Encoder counts. There's like, I don't know. There might be like 20
display.
Yeah, that are shown on the display. Just a purely text display.
Yeah, this is my sort of robot running display right now. You can't really, it's hard to focus, but it's basically just a whole lot of text as well. It's just different colors and different positions and stuff and whatnot. So it's the same basic idea. I'm just using it as a more general purpose platform.
And John's is sexier and get more chicks.
Yeah, I don't think so.
It's obviously more of a nerd magnet than a chick magnet.
Exactly.
Not necessarily a good thing.
That's a little too honest, though.
I pasted a link to my GitHub repo where I've got the code that's running on this right now. Sitting, if you want to pull it down and have a look at it. It's still in a very basic state, but the whole GUI system is there and it works. So
very cool. Thank you, John.
Yeah, I think that calls for a group project, or at least for you to productize it, so we can buy copies of that.
Well, it's all going to be open source, so it's the case is 3D printed. It has there's 4 screws holding the back on. There's 1,000 milliamp hour single cell LiPo, and I've got a little tiny slide switch soldered into the positive line from the battery, which is. You can see the USB-C port. You can't really see it, but there's a slide switch. Yeah, you can sort of see it there, right down below the USB port, and that's how I turn the thing on and off. And I've got this little 3-pin connector with, that allows me to plug in. I actually have 2 different form factors. I have a ring with a push button on it. And I thought that was a really neat thing, except it turns out that with that little push button, it gets really hard on the thumb after holding it for a minute or two to do that. So I switched to a bigger, more tactile trigger as the failsafe. But this is completely optional. And with 3 pins on this, I've got basically ground and 2 GPIO pins. And what these things do is they short out one of the GPIOs with ground, so I can tell in the code if you have a trigger plugged in or not. And then I can also tell whether you're pushing the trigger. So you don't have, if you don't want to use a failsafe for a particular robot, like you probably don't need a failsafe on a 6-can robot, then you don't need to. You just unplug it and use it like this. But if you need a failsafe, then you have that capability.
Yeah.
For full disclosure, my controller here is Bluetooth, so I just plugged a Bluetooth receiver into the Raspberry 4.
Yeah.
Yeah.
Of course, then you have to pair them.
Oh, are they paired?
Yeah.
Themselves?
Yeah, they pair really. That stuff is really easy for sure.
Yeah.
If you want to change any of the code on it, it's a whole different story.
But it's no good for outdoors because it's only like a couple meters.
Yeah.
So
Yeah.
I guess you do have. Actually, the thought just came to mind that you would have to make a program change to set the MAC address of. I suppose you could do it on the GUI to set the MAC address of what you want to talk to, I guess.
Well, no, I mean you plug an ESP32 chip into your robot. That has a fixed MAC address. It never changes. So you program that into the configuration file that you set up with all the windows and stuff for that robot. So like I have, as I said, I have, right now I've got a picture of
robot selector.
Yeah, I've got that one, and I've got my Roz, my walking robot, and I've got my tabletop robot, which there you can sort of see it there. So the idea is each one of these things will get its entire window menu subsystem, but it also knows what the MAC address, or will know what the MAC address of that robot is.
Got it.
And so when I'm in that particular part of the windowing system, any messages you send or configuration will be sent to that MAC address.
Got it.
Yeah.
I'm going to have to use something like that in the future.
Yeah.
I like that. Thanks.
Yeah, well, like I said, I'm open sourcing the whole thing, so it's all you have to do is buy one of these, and you can either. I mean, I'll be putting up the STL files for this, but I mean, really, the STL files for this are very specific to this, plus the battery that I happen to be using. So you probably want to create your own if you've got a different battery. And God knows there's like 6,000 different form factors of 1S LiPo batteries available. So I did test this today with this thing, and with the screen, like I have a screensaver that kicks in after 60 seconds that shuts the display off, which cuts the power consumption in half. Like this thing with the screen on and the ESP32 running takes about 75 or 80 milliamps. And if you turn the screen off, that drops 40 milliamps. But with 1,000 milliamp hour battery with the screen on, it'll run about 8 hours And that's with the LiPo going down to 3.4 volts, which I think is a reasonable, I could probably get down to 3.2, but 3.4 is probably a good cutoff. Actually, you can see that the screensaver's cut in, so now if I touch the screen, it comes back on again. So that, and basically I disable the screensaver when I'm running a mission so that it, I get the feedback from the sensors and whatever on the display. So yeah, I mean, the code's all out there, and I'll be continuing to update my GitHub as I, do more code and whatnot. But it's perfectly usable the way it is to build your own set of windows. It's a fairly sophisticated windowing system, so you can build a lot of stuff with it.
Yeah. So I don't have a robot that can do Robomagellan yet, but I might get that. And if a picture of Race Robot shows up on my arm, look out.
Yeah.
Very cool.
We're all safe, not unless you divulge your MAC address, So.
Yeah.
Thanks, John. I like it a lot. I think it'd be a great group project, or I think many of us could use something like that.
Yeah, it's just a lot easier, you're not bending over, chasing after your outdoor robot, looking at this, washed out little LCD to try to figure out what it's doing. You can make it large enough and bright enough.
I'm not sure how visible this is going to be in sunlight. I mean, we haven't had much sunlight around here lately, but I'm up in Ontario, so but we'll see. You can always, shade it if you need to with your body.
Okay. Nice. Thank you. Brad, you're up next.
Okay. I came across something. Let me see if I can share it. I came across a couple of videos. Can you see that?
Yeah.
Yep.
Yeah, and I'm not going to play the whole thing, but we had a discussion, maybe it was a month or two ago, about phased array. And so this, and I'll just jump around on these two videos, but it's something somebody has done and I thought was kind of interesting. Let me go ahead and play it and then
I tried to use a car proximity sensor to perform a scan of my lab. It was a super simple project, but I quickly found out that it doesn't work because the beam is too wide to get any detail. A few months back, I wanted to revisit this idea with a new approach. The way these ultrasonic distance sensors work is that they send out a short 40 kHz pulse and measure the time until the echo returns. Since we know the speed of sound, we can calculate the distance to the obstacle.
Yeah,
the frequency is not audible to humans unless...
Yeah, we all know that, but what I thought was interesting, first of all, it kind of shows, the ultrasonic waves is sort of in
water. The sonic wave creates high and lows in air pressure. You can even create a simple experiment levitating stuff on these pressure waves. But
right. And so then he shows using two of them.
Is that the wave is spreading in all directions and we can't tell where the echo is coming from.
Right.
These transducers seem directional, but they are still made to detect a wide range, to not hit anything with your...
Yeah, so then he goes into an explanation of phased array. Like we've seen this before with the sensors. I think somebody was showing a car application. And then what he does, which I thought was interesting, is he kind of shows it visibly, using ultrasonic as a phased array. He kind of develops the concept using water.
Waves overlap. They're basically adding up. So low and high cancel each other out, while high and high or low and low amplify each other. This is also called interference. If If we look closely, we might be able to see regions with stronger waves. Now, the interesting part is, if we change the timing of the pulses, the direction of those is changing.
So that's kind of cool. And then he walks through
The actual shape of these, what are called lobes. The two sources are in sync. They're basically creating highs and lows simultaneously. They have the same phase. What happens if we shift the phase of one source slightly? The angle of the lobes is changing.
So, and I mean, this is a fairly long video, and I won't make you walk through all of it, but yeah, he kind of walks through the
phased array. The beam quality improves with each added source. It's able to concentrate the power to one strong beam, the main lobe, and some weak side lobes. Changing the phase shift between the sources to shape and steer the beam is called beamforming. This tech is used everywhere, like radar, Wi-Fi, 4 and 5G antennas.
So then he walks through that, but then we kind of get to the cool part, from my perspective, which is he basically builds an array of 8 transducers on a board, right? He builds the board, so on and so forth. And so what he's doing is he's using 8 transducers to transmit the wave in a phased array, and then 1 transducer to receive the echoes from the phased array. And then he builds a mechanism for testing this. And so he has, a simulator to kind of show what he expects to get out of it. Let me see if I can actually get, I can't, there we go. Okay, so he basically walks through a simulator where he's showing the loads that he expects to get, and then he measures those using this mechanism. And so
the voltage is a little bit too high, but still we are seeing a beam compared to a single transmitter I scanned before. Let's try a lower voltage.
So what he's showing here is that it's a steerable ultrasonic wave, and that the pulses are additive. And so it's basically an application of ultrasonic transducers that I hadn't seen before. So this is where he's using a steerable ultrasonic wave to a set of these transducers. He added to that project, can you see this one?
Which one?
So it's basically a row of 8 receivers now with a red transducer. There's a...
No.
No? Okay. Let me stop sharing and start sharing the other one. There we go. Okay, so he added onto this project by switching this around. And so what he's doing is he has a phased array of receivers in one transducer. And so he goes into an
extra directions.
So there's a transmitter.
And the array records all the echoes with the phase shifts at the individual receivers. This is basically the same principle as before, but reversed.
Now, I think there's one here where he shows the output of it. If I can find it in the video. Okay. So what he did with this, I'll stop sharing. It's in there, but I'm not finding it right now. But what he did, he basically built a 3D map of the received wavefronts that he got back, and so he's basically sampling this at multiples of the Nyquist frequency to get the phase differences between the received ultrasonic waves. And so he's able to build, it's similar to a laser scan in that it provides distance to data or distance to objects and shows you the reflections back and gives you sort of a 3D map from the received data. And I thought this was kind of an interesting concept if you combine these two, where you had a steerable array of transducers and an array of receivers to collect the received data, that you could use this, to kind of hone in on objects and provide a map to where those are. I had never seen this concept done with ultrasonic transducers, and maybe some other people have, but I hadn't. So I thought this was a really cool concept.
You're not saying both the transmitter and the receiver are steerable, are you, Brad, or are you?
No. So the transmitter is steerable, and so if you slightly change, the timing of the transducers as you fire them, you can steer the wave. And that was, that first video, right? So I can steer it towards, this green, circle over here on the left, and then, advance it, through.
Yeah, I get the steered beam and how it's symmetric. You can use either steer the received waveform or steer the transmit beam. I thought you'd said that he steered both of them, and I was like, ooh, really?
No, he's only steering the transmitter, but he's detecting the phase difference between the received, waves coming back, and that can tell you the distance to the object, or it can tell you the direction of the object.
So in effect, he is steering them both.
Well, he's using a static array, but he's detecting the phase difference of the received wavefronts as they come back. He has to sample fast enough to detect that. So it's, a multiple of the since it's 40 kilohertz for a ultrasonic transducer, it's got to be at least twice that for the minimum Nyquist distance, but, multiples of that to get any kind of resolution.
But earlier you said, and I believe this is correct, that you can steer the transmitter and have an omnidirectional receiver, or you can effectively detect the phase difference between the receiver from a non-steered transmitter, and it has the same effect. You have a lobe, a directionally controlled lobe with amplification, or where it only really receives from that one direction that corresponds to the phase difference between the receivers. And so if he's got those phase differences between the receivers, then it sounds like he's steering the receiver as well.
You think it should be possible, right? Because if you think about those parabolic microphones you see in sports fields sometimes, I think that's what they're doing in the spatial domain, right? They're just taking, they're collimating the sound waves as they come in, and constructive and destructive interference superimposes on the microphone. So that's the beauty of antennas, right? They work the same way in either direction.
Right, and this, you could do something similar to this for audio over the same transducer, similar to what you were showing for your trip video, Carl, where you have really, really directional and narrow beam audio in one place using this kind of technique.
Yeah, and in this case, the guy's using 8, and in the case that I showed at the Sphere, like 200.
Yeah, so I thought it was a cool idea, and I don't know if you combine these, whether it would give you higher resolution, so you can have a steerable wavefront, in the transmitter, and then finer resolution on the receiving because you can look at phase differences between the echoes. I don't know if that would add anything or not, but it seemed like a cool idea.
Interesting question.
So anyway, I thought it was cool. That's all I got.
Yeah.
Okay. Hey, Brad, can you throw the links into the chat?
Absolutely.
Very cool. Neat stuff. Okay. Next we had David David Ackley.
Okay. I'm working on something that's way off topic. I'm working on a high-speed square wave generator, 10 megahertz square wave generator. Transition time of under a nanosecond, and I don't have any equipment that lets me actually measure how fast it is. I wondered if anybody out there has something. I'm using a Tektronix 485 that has a 350 megahertz bandwidth, which gives you a 1 nanosecond rise time. And since I'm reading a 1 nanosecond rise time, it says, you know, it's at least as fast as the scope, if not faster. And I need something that's probably a gigahertz or so. And wondered if anybody knows anybody that has one.
What's that makerspace?
I asked Doug about that, and he said that he didn't think anybody at Makerspace had anything like that.
I think they have the Rygols, and they might have done the hack to get the higher bandwidth, but I don't know that it's quite that high.
No, it's only 100. That's 100,
I've got
100
one of
megahertz.
those. I've got one of those scopes, and it's not that high.
And I don't remember them seeing decent. I don't remember seeing decent like CRT scopes there.
Okay.
Much less.
Thank you. I just thought I'd take a shot at it.
You got to find a Agilent rep.
Yeah, absolutely. Anyhow, thank you.
All right. Next up, Pat.
Hey, everybody. I had lots of fun this week trying to troubleshoot. And I'm going to show my screen.
Brad, I think you need
Brad,
to
you're still presenting. I'm going to share my troubles and tribulations. Everybody can see my screen.
Yep.
The platform I opened, and I've got it set up to use a CM-SysDAP probe. I am successfully able to troubleshoot an STM blue pill, an STM black pill, and an Arduino Zero clone using a SAMD21 chip. And with this probe, and it works perfectly fine in Platform IO. But when I get to the Renesas RA, the R4 Minima, using the same setup I have on the other ones, I am having absolutely no luck. So no matter what I try, I keep getting back in red error, unable to find matching CM-SysDAP device. And it's been driving me nuts to the point where I'm ready to dump the board. I've lost way too much time on it. In Linux, so LSUSB, it definitely sees the board. I have a UDEV rule set up using the manufacturer and the device code to allow it on for everybody in Linux, and it's working. As well, I've loaded Pi OCD in here, and Pi OCD quite simply sees the board. So it sees it, it's there. Platform IO can use it on everything except it seems this Renesas board. So it's driving me nuts. And I was just sort of wanted to see, does anybody have any idea on what other direction to go to try to troubleshoot?
Run it with sudo and see if that works.
I could try running it with sudo.
And that will tell you whether it's a permissions issue with the UDEV rules or whatever.
I don't know if I can run Platform IO from sudo without having a specific.
Well, however it is that you launched that thing that you were.
Yeah, so it's not going to find it there. So here, like in the terminal, I can find the device. It's no big deal. UDEV rules run under sudo. They run on boot up.
Yeah.
But Platform IO, I don't think I can run as an admin. Not easily, anyway. I'd have to find the command for it.
So I missed the first 10 seconds, I think, but you're saying Platform IO can't open the serial port?
It can't find the device. So it works successfully with a black pill and that probe. It works successfully with a blue pill in that probe. And it works successfully with an Arduino Zero clone, a SAMD21 clone board through the SWD port, and it works. But when I try to do it here under debug, and try to do a download to it, it comes up and it tells me unable to find a matching CMSys device.
Pat, is that something in the Platform IO file that's screwed up?
Well, that's what I'm beginning to wonder is if they've never properly set this up in the Platform IO file.
But so you said you used this debug protocol, CMSys DAP, the tool. You've used it with other boards?
Definitely with other boards. And essentially identical setup, just declaring a debug tool, declaring an upload port, upload protocol, and it's finding it. It works out of the box.
So same debug tool, just different target board.
Yeah. These three are different.
Okay, so if it's the same debug tool, that means Platform IO is able to talk to the debug tool.
Yeah.
But then if you're having trouble with the R4 minima, so maybe the debug tool is not liking something. So one thing I find sometimes useful, and you might have to, I don't know if you're going to have to download OpenOCD separately or if you can find it where it's installed, but sometimes troubleshooting something like that, if you just directly invoke OpenOCD with different parameters, just to see if you can get OpenOCD to talk to your board. So you take Platform IO out of the equation. You just use OpenOCD directly.
So it's to try to do it with OpenOCD. So I have to find out where OpenOCD hides its stuff. So it gets loaded with Platform IO.
You can also install it
right
separately.
Tool-OpenOCD.
Separately.
I didn't quite get all that. There was two people talking.
There was a folder. If you go back to where you were just looking, tool-OpenOCD.
This guy
might be there.
There we go. So it's in the bin folder, and then it's in the bin folder. Go one level up, and then that's where the executable is, and then the scripts and all kinds of include files that OpenOCD relies upon are in the OpenOCD shared scripts folder right there. So there are all kinds of files that get passed in. Sometimes they're board specific, some of them are CPU specific, some of them are debug tool specific. Now, I wonder if there's something in there for the Arduino R4 minima.
Knowing Renaissance is probably something they forgot to tell you.
Well, I've been looking for the different config files and trying to find stuff. And
go to the top. Is there something there under A for Arduino?
Nope. Under scripts?
Well, I mean, ideally it would be on the board. If the board is explicitly supported, it would be there, but But if it's not, if at least now go back to your platform IO window. What is it passing in for parameters? Is it telling us what it's passing in?
No.
You may have to, there's a way to tell it to be more verbose, and I don't remember exactly how. But that would also help if you can see what it's passing in.
Yeah, I tried passing in a port. So saying localhost and go to 3333.
Is the board the UNO R4 minima?
Yes.
Okay, maybe check in that folder for that, or did you already do that?
Well, I've never dug that deep into that folder before, so.
No, in the board folder, in scripts in the board folder, is there a UNO?
There is under UNO. No, Uno.
Okay.
So there is a.
That might be the real problem. If you don't have a configuration file for the board that you're looking for, then that may be what it's talking about.
Well, that's why it would be good to see what platform IO is passing into OpenOCD for command line. You'll have to Google how to make that output more verbose, because I don't remember. And then once you know that command line, you could replicate that separately on a command prompt and tweak the command line and play with it a little.
Yeah, I was just looking if I could see my 411 here. So my 103 blue pill is basically, that's what it's just passing a source target.
Yeah, sometimes the board-specific files are really simple. They define a few things, and then they go straight into like a, CPU-specific file. Exactly, just defines and flash size, like here.
Isn't there a target folder under scripts?
All right, Renaissance R, I don't see any R4 in there.
Yeah.
Try Uno in there.
No, see, Uno would be the board, right? Not the target.
Yeah. Uno would be an ARM board. Not Amiga?
No, Uno is just Uno won't be supported. It doesn't have a JTAG.
Yeah, it doesn't have the port.
Interface.
So like an STM32 I was looking at earlier.
Yeah, those are the name of the chips in here.
So
right, those are the names of the chips. So that's why you're looking for Renesas, R4.
It's going to be fun to make this up by hand if I have to.
No, you don't want to do that. So. But what did they say on the Platform IO website? Didn't they say it's supported?
They say it's supported. Yeah, by default it's supported. The CMIS-app. So I would have to try to find a config file somewhere for it.
You could use the find command, maybe looking for a string that you think would match in something that works, and on your Renesas, search for a Uno something or other from OpenOCD directory or from the scripts directory. You know how to use find?
A little bit, yeah. So I can search.
Pat, I just posted a link to the chat for somebody who looks like they're having an identical problem.
Oh, there's a lot of people having identical problems.
Yeah, it looks like as of November, they didn't, at least at November, they didn't have support.
And which is interesting because Platform IO says they have support right out of the, it's the default debugger for it.
That's a bad sign when there's a bunch of people with the same problem.
Yeah, well, this guy has an actual solution.
Oh.
Can you, is that link, did you,
it's in the chat.
Okay, good.
Yeah, I got it open I've got it open in my other window. I'm just looking through it. Well, I'll have to go through. There's a lot here to go through.
Yeah, so he's passing in some file, some config file, some script basically.
Oh, yeah. He has the command line right there.
Yeah, it's just a -F and then a path to one of those CFG files that maybe he created, and I think there's a link for it.
Yeah, well, that's what I was just looking at. There was
Now the link to the config, okay, the config file is, I guess, actually under the Arduino GitHub repo. Yeah, so if you try out that command line, you get that file, try out that same command line, and you see if you get any further.
Yeah, well, it's a good website. I'd come across it before, but I dismissed it because he was using Zadig software and on a Windows system, and I sort of said, well, I'm not going to find it. I'm using a Linux system.
Yeah, on Linux you shouldn't have, you won't have to worry about that Zadig thing. That's a Windows thing.
Yeah. But he's got, he's got some info and some GitHub stuff to go look at. And so it's interesting that I did find a reference to the Uno R4 Wi-Fi and the Uno R4 Minima in Platform IO under some of their stuff, and the tools available were quite different on both. And so in that folder, and I was wondering, okay, well, the CM sysapps wasn't listed on the R4 Minima file that I found. So I tried manually adding it in to say, okay, well, if it's just missing the declaration for it, let's add it in and try it. But I had no luck with that at all either. So I agree. I don't think it's finding a config file to run it, so it doesn't have a clue what to do. So that's it. That's my trials and tribulations for the week. Thank you very much, guys. I think you've given me another direction to look. I've been looking for these config files for a while, and totally missed it. So I've got an idea where the scripts and the targets are, and I can see what it's sort of doing on its own there. If this doesn't work, well, plan B. I mean D.
Good luck, Pat.
Thanks.
Ray was up next.
You're muted, Ray.
You're muted.
Oh, I was saying some of this is probably old hat for John, but it's new for me. I got two of these boards. This is the MKS dual Foc. This one is the plus. It's got discrete MOSFETs. And this one I think is based on, I'm going to say the 6234 part or brushless DC motor driver. Anyway, this one will do about 5 amps. This one's supposed to do 12 max. They seem awfully.
Something?
Whoops! Oh, I guess I gotta present, don't I? Nope. Screwed up there. Okay. Share. Okay. Now you should be able to see it. Okay. Details. Yeah, I bought two of these. The one on the right here. It's made with discrete MOSFETs, and it's much higher, much more current. I think this one's rated for 5 amps max, and this one's rated for 12 amps max. And
really?
Yeah.
Wow. Definitely drop a link for that, please.
Oh, okay. Yeah, so there's the one. That's the 5 amp.
Actually, that's the same company that makes the maker base. That makes the Simple Foc Mini.
Yep. And what's kind of neat about these, let's see if this is, I don't know, screwy advertising here. Okay, they give you these two connectors, and you can buy it with an ESP32 board. And I thought, okay, well, how do those connect to each other? And actually, on the back side of both boards is, the pattern to solder these down, and you basically stick the ESP32 on the back of the board.
Surface. It's a surface mount connector.
These are
those guys. Yeah.
Yeah, and like I said, this one is not very forgiving. I screwed up one of them. I don't know if it's just kind of a thing the way it was designed, but he's got a little switch mode power supply up here that generates 5 volts and 3.3 volts. And these two chips use the 5 volts to generate a higher voltage to switch on the upper MOSFETs in each of the half bridges. And so it's like a little DC to DC converter around, off the drive circuitry that drives the upper FETs. And if there's a short on one of the FETs, it brings down this 12 volts and then does all kinds of weird things. Anyway, so I'm hoping it was nothing I did, and I ordered another one to see if it was. And I've also played around with, let's see here. Okay, I didn't get them from AliExpress. I think I actually got those. Basically the Simple Foc Minis, they're based on I think it was a TI part, 83 something. I forget what it was.
Yeah.
And I also got these gimbal motors, and those have the AS 5400s built into the bottom of them, and they include a magnet. The magnets are just glued on, and to basically try to mount something, I took this screw out. It zapped over to the magnet, and when I tried to pull it off the magnet with the tweezers, the magnet and the screw came off. So I had to re-glue it back on, and the code compensates for a magnet that's not electrically aligned with, like, the A, B, or C phase transition. It's kind of arbitrary where it ends up, but it can actually figure out what the offset is. So if you're doing closed loop mode.
Are you using the Simple Foc library, or?
Yeah.
It does a pretty good job at that.
Yeah. Anyway, so this is the, Simple Foc closed loop position, one of the routines that you can use. And right now I've got it running with the two motors, and I've told it to go to, basically -1 revolution, or, 2 pi, 6.28. And so I can change it to go, like, say, back to 0. And you can see they both go back to 0. And what's kind of neat is you can basically twist one and get it off its 0 position. And if you let it go, it snaps right back.
Ray, are you showing us motors? I'm not seeing the motors.
No. I was going to try to get my phone camera up, because if I rotate my laptop, it'll screw everything. I don't know if you could see right here, the 2 zeros. Yeah. Anyway, so I can try to get this on. It's a fairly simple setup. I've got an ESP32, connected to the Simple Foc Minis, which I think John has used. And then, that's actually driving the 2 gimbal motors. And
I'm actually surprised it'll drive 2 motors at the same time. That's a significant amount of processing.
Oh, yeah. Well, the ESP is pretty fast, and
I suppose it is a lot. I was using an RP2040, which runs at about half the speed of an ESP32, so that's not surprising.
Okay, let me see if I can show you the image here.
I've put that project on the shelf for now because I've got too many things going on.
And I may have to turn off one of my mics here, otherwise I'll get screaming feedback. Okay. I'm going to stop sharing on that. And mute the mic.
I can't hear you.
Okay, can you hear me now?
Yep.
Okay. Okay. Hey, is there feedback now?
Echo.
No, you're talking, but you're muted.
Yeah, they're both muted.
you've got your phone on face camera.
I can't seem to switch it.
Ooh, crickets.
Just kind of a rat's nest on the bench there. This is the ESP32 here. And here are the two simple Focs, and then over there are the two motors. And there it's position control, so I'm going to get out of that.
I had to be really careful. Sometimes my motors got really hot if you don't limit the current properly.
Yep. Okay, God, I can't get this thing on. Okay, I think, nope. All right. Okay, no, it's still there. God. Okay, there's going to be an echo. Okay, where are you? God, I hate this phone. Things disappear and you can't find where they go. Okay, should have killed it. Anyway, yeah, one of the things that I found out. Let's see, where is it? There's a thing called motor voltage limit, and if you set it around 1 volt, that's very conservative. It doesn't, it really limits the amount of current going through the motor. Some of these programs started it out with like 4, which, corresponds to 4 amps. And it is, way too much power in the motors. The motors got hot and it's like, oh, okay, let's, turn everything off, let it cool down. Try to figure out what it was, looked at some of the other programs and said, oh, okay, well, they have the voltage limit set to 1 on some of these other things. So, lowered all the voltage limits down and kind of started over and got much better results. Anyway, like in the closed loop position program, if you want your motors to respond faster, you can increase that voltage limit, and it you can see it on the power supply. The amount of current goes up, and it's actually worse when. It's actually worse in open loop because the open loop, the position isn't monitored, and you can get very high currents in open loop, both for velocity and for position. But the faster you go, the less current it draws. It's only at the very, very slow speeds, or in the case of position, if it's open loop, will you draw high current. So
one of the things you're going to find if you switch your AS5600s to run in I2C mode instead of PWM mode, you'll get much better response for closed loop.
Yeah, right now they are on I2C mode. Yeah.
Oh, you're running I2. Okay, then you're cool.
Yeah. Yeah, that was the other thing on one of the pages. It said, they have this little teeny 3-pin motor connector that connects to the ABC phases of the brushless motor. I said, oh well, you can cut that off and stick your own connector on there. With it, they actually sent this little teeny adapter board that had a receptacle for that motor plug to fit in, and then a larger, I don't know, they might be, I don't know that they're 1/10 spacing. They may be like 2 millimeter spacing. At 1/10 of an inch versus, 2 millimeters. Anyway, so they had basically a little printed circuit board with the 2 connectors on it. But at that point, I had already cut the connector off, thinking,
yeah.
It's like, okay, don't do that.
Oh, I always cut the connectors off for stuff like that because the ones they give you are worthless.
Yeah, I mean, I didn't have a mate to it, so at least I didn't think I did. Initially, it looked like they had, I thought for some reason they gave me 2 of the AS54 boards because they're about that size. And I thought, oh, okay, well, that's nice. And then looked at it later, and it's like, because the AS5400 boards have 2 connectors on the bottom of it. And they're different size. And I thought, just kind of looked at it real quick and, threw it back in the box. And that's what that connector was for. So, anyway, so you're putting your project on hold right now?
Yeah. I've got, well, I mean, this thing is consuming a lot of my project time, and I decided to just work on one robot for now, and I'd rather have the Robomagellan robot. Not because I want to do Robomagellan, but because I want to do outdoor navigation and
stuff,
messing around.
Yeah.
So are these going to be drive motors for an indoor robot? Is that what your 2?
Yeah, I've got like 3 different sizes of motors. The actual platform.
Brad, did you see my little white robot?
Yes, I did.
Okay, so that's that's my version of that.
Yeah. Anyway, this has 2 pretty good size brushless DC motors with
holy crap
encoders on the back, optical encoders, and so this is the largest size that I have. They're Elcon motors, and I can look up the specs on them. The other ones are smaller. So this is, I think SMI was the manufacturer of this. I can't find any information on it, but I know where all the wires go to, and even the wires that go to the encoder in the back. And so this one actually has the ABC phases of, for the windings. It's got, the 3 Hall effect sensors, and it's got, it's kind of weird. I don't know why they would do that, but it's got an encoder with like 2 separate quadrature channels, and the second set is the complement of the first set. So logically, so when one is high, the other is low. So I'm not certain why you need 2 sets of outputs from.
So you're saying it has 2 AB pairs?
Yeah, there's.
Oh, that is weird.
there's 6 wires on the back of it. And all 6 are used. 2 are for power and ground. 2 are 1 pair, quadrature pair, and the other is the second quadrature pair, but complementary to the first pair. And this one is a little bit simpler. It just has the 3 phases for the motor, and then one of the heads, like HP used to make encoders, optical encoders on it. And either, any one of them would be, I think, strong enough to use on a small indoor platform. That's why I wanted to buy that larger motor driver. I think they said there's like a 10 ohm cutoff that the simple Foc minis will do, and they say if it's less than 10 ohms, you really should use a larger driver or a driver with higher capacity. So that's why I got the other 2 sets. So
yeah, this is one of the brushless motors I would use for something like that, for a bigger robot.
Yeah.
But I suspect this one you'd need a 5 or 10 amp driver for it. So
right, yeah. Anyway, so you can do some pretty neat things. Like you've already got PID constants to do closed loop velocity or position control. So that's kind of neat, and it's kind of like the thing that Kareem was doing with his robot platform in the odometry pods. They could kick it or bump it, and it would move back to its original position because it sensed that, it wasn't at the position that it was told to go to. So, so I'm thinking you can really, with those 2 things, fairly easy, or have it be fairly easy to be able to program, motions, complex motions, because pretty much all the work is done already, and the boards are pretty compact. I just got to be careful with motor voltage limits from the get-go, and not, start things up a little too powerful, because that's where they say if you look at the manual, it says violent vibrations can burn the part. So it's like, okay, don't know how you avoid those violent, things, but because they certainly don't tell you, oh, well, here's a parameter that you need to start this off at 1 volt, not 12 volts, things like that. So
there's a really good Discord channel for Simple Foc that has a lot of people who know an awful lot about how all this stuff works.
Yeah.
I've gotten a lot of help from them.
Okay, good. Anyway, yeah, so I wanted to get some experience with, 3-phase brushless motors, and, the Simple Foc minis aren't very expensive, and the gimbal motors are like $16 each. So, and I had my, my Tanner collection of other stepper motors for a long time, so figured I might as well put them to use. So.
That's cool. I'm very interested in your experience with those. So one problem I have, we're kind of talking about this last week, is that sizing these motors for a robot. I think it's kind of a basic thing, and I have screwed this up so many different ways in a previous robot I built. That it's, I know that the no load speed and the torque, kind of tell you what power or what power you're going to pull. But as far as sizing, the current pull from one of these brushless motors, if you look at like some of the drone motors or some of the some of the RC motors, they're pulling a ton of current through those.
Mm-hmm.
And so the ESCs for those that you normally use to drive a brushless motor are pulling tons of current, and it just doesn't seem like you would need that for an indoor robot. So kind of how you determine, that for me, being, out of doing design for a while, it's kind of an unknown. I don't have any rules of thumb for sizing that.
Yeah. In the specifications for that for those two gimbal motors, basically the torque specification is it provides good torque. It's like, oh, okay, it's good torque.
Yeah. So the main difference between like this one here looks like one of those drone motors, but this is a 360 kV motor. And the typical drone motor will be like, 7,000 or 8,000 kV or 20,000 kV for the really fast ones. This is 360 kV. I mean, this is a gimbal motor. It's just a big gimbal motor. So that's the thing you want to look for if you want a motor that has more torque and goes slower, is a lower kV rating.
Right. So that, if I understand right, that kV rating kind of corresponds to the no load angular speed as well, right? Isn't it like 10 times?
Yeah, it's effectively RPMs per volt or something like that.
Right. Okay.
It's directly proportional to RPMs per volt. So it's yeah.
Right. So max power for those would be basically no load angular speed is like one side of it, and stall current would be the other side of it, the other side of the line, right? And so max power is going to happen in the middle of that point. Is that how that works? I'm saying that completely screwed.
No idea.
Okay.
Yeah, and I know the like the hoverboard motors, and they call them pole pairs, but they're actually, I think they mean like pole triplets, right? Because there's no pairs. It's three windings. So if you have multiple pairs, it's really multiple triplets. So like the hoverboard motors, I think, have 16 pole pairs. This guy has 4, and I can't even tell what these are because there's no detent. You can kind of spin the shaft and not even feel a detent. But the gimbal motors are 7, so the motors with more pole pairs are going to rotate slower and have more torque.
Right. The pole pairs, don't those relate to the permanent magnets, not the windings? That's what I always thought.
Oh, I thought it referred to the number of windings, like that motor that John showed. Those aren't individual poles. 3 of them are wired. I'm not certain actually how they're wired.
Yeah.
I don't know if they're in series or in parallel.
Yeah, no idea. I know the little black gimbal motors that I use are 7.
Right. Yeah. So the more pole pairs, the slower it rotates, and probably much lower the kV is as well.
Oh, is that it?
Well,
yeah. I have a much bigger one here too. One of these ones. These are the kind that you use on, like, the dogs, like the cheetah or whatever. But these ones require a much more. This is like a 40 or 50 amp driver board. For this, I have I only bought one of these because they're ridiculously expensive. But this is an O drive.
Mm-hmm.
This is like $150 or $200 for this board. But if you want to build a robot dog, you need 12 of them.
Well, that's all. Yeah.
Yeah, so it's $3,000 or $4,000. It's not a big deal. But yeah, these things are ginormous. If I was building an outdoor rover with brushless motors, like a moon rover or something, I'd be using these for sure. Yep.
Yeah, I looked all over for what is the actual torque. I mean, I even went to the manufacturer, but their website's all in Chinese. You can't translate it. So I'm not certain what it is. It's at this point, it's just good torque. So.
Yeah. It's what we call a WAG, a wild ass guess.
Wild ass guess. Yeah, that's about it. So
that's how I do all my stuff.
So John, that motor that you just showed, the Cheetah, how would that correspond or compare to like a hub motor on like a hoverboard or a ESP?
I'm sure it's very similar to the kind of motor you would get from one of those hoverboards. I mean, if you put a lot of people take that specific motor and they'll put a 10-to-1 cycloidal gear reducer on it, and that motor will produce something like 24 Newton meters of torque, which is just like an absolutely insane amount of torque. And so, yeah, they're you could drive almost anything with that.
Yeah. Well, I know the ratings on the hoverboards, the weight limit is 250 pounds, and supposedly it'll push you along at like 6.5 miles an hour. So, again, if that's a fair amount of torque to be able to do that. So,
yeah.
Shortly before you fall off and break your neck. Anyway, that was all I had.
You're muted, Paul.
Yeah. Thank you. And speaking of muting, Doug, I muted you because we were getting a lot of clicks from you. So that's the end of the list that I had so far. In the process of talking, did anyone else come up with items they want to talk about? I did. I got a new robot, so I'm excited about that. Anyone else want to start a second list or get on a second list? If not, we'll roll into general discussion. Okay, so here's my big excitement. I got myself a PiDog, and came with a whole pile of parts. Doug got one of these, turned me onto it, and there's a whole pile of boards and a whole pile of metal plates and a whole pile of servos and wire cables, and I'm busy, putting it all together at the moment.
So those are 2 servos per leg?
Yes.
Okay.
Yeah. And like Doug was saying last week, they're pretty inexpensive, like 180, I think, for the robot, and then you have to add an RPI to it. But that's pretty inexpensive.
Yeah.
So, excited about that. Okay, open mic.
I guess it's
before you asked me a question by email. You said you thought the assembly videos were fuzzy, and yeah. I can't tell you because the big assembly instructions that they had, that was so good. I had no problem. I just followed it along step by step.
Oh, okay.
So I never used the videos.
Okay. Well, thanks.
Yeah.
It's a lot easier to get the wife to approve that than like a Boston Dynamics spot or something.
Yep.
Well, interestingly, I was looking around at robot dogs, and there's one. I've forgotten its name, but it its claim to fame is it's ROS compatible, and they got the whole navigation stack on and everything on it, lidar and all, but it's like $500, and so I was like, and it didn't look like it was a kit that you would assemble the way this is, and so I was like, no, I think it should be easy enough to put ROS on it, because it's got an RPi, it runs on the whole robot runs on Python, so you can run that inside of a container, of a ROS container. I think it should just integrate fine.
You might consider using a Pi 4 though.
I did get an 8 gigabyte Pi 4.
Yeah.
Yeah, if it's got a lot of little screws, you need to get one of these things. It's got 5 little prongs. You stick the little small easy drop screw in the end of it there, and
I like that.
Put it in, and at least get it started. And then,
what do you call them?
I don't know. I've had this one for a while. I know Micro Center carries it. It's like a screwdriver. It's got like 5 little 5 little prongs that come out the end.
I've got a big one, but that's a great idea, Ray. Thank you.
This is what I used for putting small stuff together.
Oh yeah?
It's an Aeromax, and it basically works. You push the button and twist, and then it starts running. You can see it's running there.
Yeah.
And you can twist in the other direction to take things off, and it's got a whole enormous set of different bits, and it is fantastic for saving your wrist.
I like that.
On small things.
An Aeromax. What do you?
Yeah.
It's a screwdriver, electric screwdriver.
Yeah. It's there's a zillion clones of them on Alley, but you get like a whole set of different bits that come with it, and they have a drill and they also have a Dremel-like thing, which is completely worthless. The drill is reasonable, though it's not very fast, but it's nice for doing really precision work because it's so light. But this thing is the workhorse. And if you use a lot of M2 or M1.4 screws, you can't beat this.
Cool, thank you.
Yeah, I took one of the screws out of the encoders off back of one of those motors, and I was using these tweezers basically to hold it and start it with a screwdriver. And of course it,
jumped,
sprung out of the tweezers and went across my desk, and it took me like 10 minutes just to find it, Like, oh my God.
So this is what I do. I hold the screw with my finger on the bit, because I use hex screws, like hex head screws, and then I push the button and then start spinning, and
you can actually get it started.
It gets started like that while you're holding it, and then you can just let go and keep it screwing in, and you don't have to sit there and constantly move your hand while you're trying to turn the screwdriver and stuff. And it charges with the USB-C.
Jan, can you put a link for that tool? That'd be really nice.
I got it off Kickstarter, but they have a whole store. Yeah, I'll find it here.
Yeah, because there's so many of those on Amazon, and a lot of them are pretty bad.
Yeah, you can get this one on Amazon. Actually, it's $100 Canadian.
Yeah.
I don't know. Let me get a US. Well, I'll do both since we have a bunch of Canadians here as well.
Woo.
So that's a horrible link. Jeez.
Oh yeah.
I should have cut that down.
Yeah, I put one in there that's humongous. Sorry about that.
So Yeah, it's $40 on Amazon.com. Okay, just a sec. Let me grab it here. All right. That's a better link.
Yeah.
Now that's getting down to more like my kind of price level.
Yeah, and it's a fantastic screwdriver. I mean, it's really well made. It's got a nice. It doesn't feel like a plastic toy. I mean, it's got a machined aluminum enclosure, and it's got a nice little OLED LCD panel on there. It shows you the battery level, and you can set different torque levels. Although I normally just keep it on automatic.
Well, thanks for the tip. I'm gonna. That's in my cart. I'm gonna get that.
Yeah. But yeah, those little 5-fingered things look really cool too for getting this one. You can't get some hard to reach areas with this, so that would be handy.
They've got some 4-prong grabbers on Amazon as well.
Yeah, and the Aeromax uses the standard 4mm tools, so you can buy extensions and things. This is one that came with it, but you can buy these like off Amazon or anywhere, and there's all kinds of different tool ends you can get that use this standard size.
Oh yeah, they call it a jeweler's pickup tool, like $4.50.
Yep.
Yeah.
Perfect.
Electronics.
Perfect. All right.
So with that, you'll be able to show it walking next meeting, right?
Could happen. Hey, I'm a retired guy.
Oh, I might as well be retired as much time as I'm spending lately.
I'd like to be retired, but can't quite yet.
All right.
Lately, my work is interfering with my retirement.
Yeah. I did pick up a robot. I guess I could show it real quick, but it's not a kit per se. I got a Create 3 when it was on sale. Let me see if I can show it. I'll go grab it real quick. 1 second.
Is that one of the iRobot bases?
Yeah, that was my first robot.
Oh, okay.
Well, not quite the first, because I used the club's red tank robot as my first robot.
Yeah, I don't know if you can see this guy here.
Yeah.
Yeah. So basically, I mean, it's a Roomba, but the reason I got it is it supports ROS 2, and so a lot of the routines it has are interfaces to the onboard sensors that are available through ROS 2, and so I kind of wanted to use that as a kind of a start for figuring out how to integrate my other robots to ROS 2 and do the interfaces. But I haven't done a single thing with this thing yet. I kind of want to get my basic code working before I do that. ROS 2 is something I'm trying to do later, but you can program it in Python. You can use the ROS 2 stack. It's already got most of the simulation models and URDF and interface code out there. So there's already models for this to run in Gazebo, as well as Isaac Sim and some of the other packages you might be interested in, interfacing to ROS, if that's something. And it's a little expensive, I think, I think I spent like $2.99 or $3.99. I can't remember. So it's a little high for what you get, but I don't know if you can see the top, but there's a grid of holes in there that you can mount like your Raspberry Pi with your cameras on, or Jetson or whatever you want to use to do whatever visual stuff you might want to do. So, and it turns out for some of the turtle bots that you see a lot of people use for ROS, for learning ROS 2 or for demonstrating ROS 2, and some of the the navigations. This is kind of the base that they're using, and they're building on top of it. So I thought it was kind of interesting as kind of a starter project where since I suck at hardware design apparently, it might be okay.
Brad,
yeah.
Brad, I was going to say, I think that Ross, when it was part of TurtleBot or whatever no, what was the name of it, Paul? It was Turtle something.
Yeah, it was a TurtleBot.
TurtleBot.
Willow Garage.
Willow Garage, when it was with Willow Garage, it used that platform, the earlier, version 1 of that platform. So that probably is a good choice to get what you want to do.
So you said you can program it in Python. Do you mean you can actually program a computer that's inside the robot?
Yeah, it looks like it. It looks like there's interface code. So the way, as much as I've played with it so far, they've got sort of a web-based programming environment that talks to this thing. So it's got Wi-Fi inside, so it'll link. Their interface will link to this robot and find it. Do the I don't know. It'll pair with this robot.
I thought the ROS 2 integration was that whole robot was a node, and you talk to the node to tell it to do things. That's what I thought that was.
Yep.
It's not. It doesn't really have. It doesn't have a little. There has some kind of processor on there enough to do the nodes stuff and be able to connect up. But basically, you probably got a model and you send it down commands. I wonder how many things they expose on that. Do they? I mean, they expose
a lot. It looks like they exposed all of the sensor interfaces. So if you go to their Create 3 page and look at that, you can bring up the web interface and program it apparently you can program it with Python using the web interface. And if you look at the APIs that they present,
what I was asking was how many message or topics does it expose? Is it just a couple, or do you get one per sensor, or you get one for the robot that has a whole bunch of configs behind it?
Yeah, I don't know that yet. It looks like they're exposing all the sensors, but if those are separate topics or not, I couldn't tell you at this point.
Okay.
So that doesn't actually have vacuum parts, right?
Does it have a LiDAR in
it? It does not have LiDAR.
Okay. And did you say it had the vacuum parts or no?
No. So if you look, I don't know if you can see it. So it's got a drawer. If I can figure out how to get at it. It's got a shelf that you can put more parts. Whatever controllers or batteries that you need to run the stuff that you're running, either in this drawer or on top for additional sensors.
Yep.
You can do it that way. And then they send an extra one. So it looks like you could, cable up a couple of different, models, like maybe a Nucleo one, or maybe a, RPi one, or whatever, or different battery configurations. Plug and play that.
Yeah, but I think what you were talking about, Harold, I think you're right. There's no central processor per se on this. Just a lot of exposed sensors and whatnot.
I suspect it's got an ESP32 on it that's running micro ROS, which then gives you a wireless interface to a ROS 2 node running on your laptop or whatever, which is where you write the Python code.
Right.
Right.
The original ones, you had to buy a separate module that had processors on it. It didn't in itself have processor. It just had the sensors and an API to get to the sensors.
Right. And there is an interface, hardwire interface to the onboard, but I don't know much of, at all about that yet. So I suspect that, it's a serial link to whatever's, running.
It's going to be cool. That's going to be a cool journey. We'll be watching, Brad.
Yeah. We didn't expect to be put on the spot and grilled like that, did you?
I don't know anything about it. I just got it. So there you go. But
it comes in a cardboard box.
New robots. Yay.
It's fantastic.
So it's a new robot. Is that a cardboard star instead of a gold star or a black star?
I'd have to make it moving for that. I did get it out and run it up and back across the floor when it came in to make sure it worked, but that's as far as I got. And that was on the web interface. Anyway.
Cool. Anyone else been up to anything? Or if not, maybe we should think about winding it up. Winding up. I'm seeing moves for winding up. All right.
A bunch of waves.
Good talk. Good evening. Lots of good content tonight, guys. Thanks.
Great session. Yep.
I learned a lot.
All right.
Yeah, well, I did manage to submit those new events to the Makerspace, so we should hear in 2 or 3 days.
Perfect. Thank you very much, Carl.
Yeah. Yep.
All right.
All right,
good
guys.
night, everyone, and see you next week.
Good night.
Yeah.